Hello and welcome to this A-Level Chemistry video where I'll be helping you to prepare for AQA Paper 2, which is Organic and Physical Chemistry. Specifically, I'll be looking at which physical chemistry topics, or parts of topics, are most important to revise. We'll look briefly at the physical topics that can be assessed on Paper 2, then look at the parts that were not tested on Paper 1, and for each of these I'll explore how those topics link to organic chemistry, which is the main focus for Paper 2. Paper 2 is Physical and Organic Chemistry, and the 6 topics I'm showing here are physical chemistry topics that can be on Paper 2, and the top 4 topics are also assessed on Paper 1, so I'll look at which parts of those topics haven't been assessed on Paper 1, which makes them more likely to be assessed on Paper 2. And this will hopefully prove useful because some of these topics are very big, so a specific focus should improve the efficiency of your revision. These bottom 2 are only on Paper 2, and so we don't have any more details about that, except to say that there wasn't a graph to plot on Paper 1, which makes an Arrhenius equation graph plotting question a little bit more likely for Paper 2. Amount of substance is normally a huge part of chemistry papers, and there were some big topics that didn't come up on Paper 1. Firstly, the ideal gas equation. It comes up almost every year, so if it comes up on Paper 2, the most likely topic where it's relevant is something like alcohols. I could see a combustion of fuel experiment where you would work out the volume of a particular gas produced. And remember that in the ideal gas equation, volumes are in cubic meters. Next, we have yield and percentage yield. This is applicable to any organic synthesis at all, really, so could easily be woven into any organic preparation, as could atom economy, both in terms of the percentage calculation and then something maybe commenting on the efficiency or perhaps minimizing the waste for any organic synthesis. We didn't have any water of crystallization questions on Paper 1, and it is harder to see how this could be woven into a Paper 2. Maybe that means that they're saving it for Paper 3. Percentage uncertainty is another thing that wasn't on Paper 1, and it's likely that if this comes up, it would only be worth 1 mark, but they could follow it up with a question asking you how a particular percentage uncertainty value could be reduced, and you would need to describe taking a larger reading perhaps because there was a restriction about having to use the same equipment as before. For the bonding topic, something not tested on Paper 1 that is highly relevant is comparing melting points and boiling points of different substances. And I fancy this to be perhaps about the oxidation of alcohols experiment, because that brings in 3 different types of chemicals. We have alcohols being oxidized to aldehydes or ketones, depending on whether it's primary or secondary alcohols. And then if it was a primary alcohol, perhaps being oxidized further into a carboxylic acid, and commenting on the melting and boiling points of those things. Connected to this and the justification for the pattern in boiling points are intermolecular forces, because alcohols have hydrogen bonding, which are a stronger type of intermolecular force than aldehydes and ketones, which only have permanent dipole-dipole forces, and carboxylic acids have hydrogen bonding. Connected to this, they could also ask you to draw the hydrogen bonding present in a substance, and if we're linking it to the oxidation of alcohols, it's very likely that this might be between 2 molecules of methanol, for instance. Additionally, they could ask you to compare the melting point or boiling point for polar or non-polar molecules, with the particularly tricky bit being that if we can have a molecule with polar bonds, but they are non-polar molecules overall, because perhaps they are fully symmetrical molecules. When we look at the energetics topic, the biggest bit of energetics that wasn't on Paper 1 is calorimetry. And since Paper 2 likes to make its reactions organic in focus, I'd say that the combustion of fuel is the most likely focus for a calorimetry calculation. And the focus here would be to have a fuel burning, and that energy would be released and then captured by a container of water above it. And you would measure the temperature rise, delta T. But not all of that energy would, of course, be captured by the water. Some heat would be lost to the surroundings. This is a good chance for a graph question as well, where you plot temperature against time and then extrapolate two best fit lines to the point of mixing to find delta T. And then you'd calculate the energy change using Q equals mc delta T, where m is the mass of water that you've heated. And then you'd calculate the enthalpy change using delta H equals Q divided by N, where N is the moles of fuel that you've burned. Or they could make you work backwards in order to find that temperature change, which uses all of the same skills but can be a bit trickier. In terms of Equilibria, there was a little Le Chatelier's principle on paper 1, so perhaps that won't come up again at all. But there were no questions about the equilibrium constant Kp, and that can't come up on paper 2, so perhaps they're saving that ready for paper 3. I think an equilibrium constant Kc calculation is a good bet for paper 2, as well as which we could explore the factors affecting the value of Kc. The Kc calculation links up well with an esterification reaction. So I could see the Kc calculation forming part of a larger question about carboxylic acids and esterification, perhaps then leading into ester hydrolysis. So that's a quick look at the parts of physical chemistry that are a bit more likely to come up on paper 2, given that they were not assessed on paper 1. Of course, you should try to revise everything that you possibly can, but when you get closer to an exam, you want to know which topics are a good idea to prioritise. To help you with your revision, I've added a document into the description for this video that has links to all of my videos to provide you easy access to the ones that you need to use. Okay, good luck everybody.